Object X is placed against a ruler. So object X stretches from one end of the ruler to the point 1.1 cm of the first ruler. So now the first ruler is placed against another ruler to measure the end correction. So that means we are measuring from this end of the ruler to the point 1.1 cm here. So on the second ruler, it reads 1, 1.1, 1.2, 1.3 cm. So the length of object X should be 1.3 cm. Okay, in these questions, we are supposed to identify how many vectors quantities are contained in these three equations. So let's just recap. Vectors involves directions and scalars does not. Okay, now let's go through each of the quantities here. Power is a scalar, work is a scalar, time is also a scalar. Force involves direction, so it's a vector. Mass is a scalar, acceleration is a vector, velocity is also a vector, displacement is a vector, and time is a scalar. So altogether, there are 4 vector quantities. A racing car is fitted with an electronic monitoring system. So data from the car are used to plot the speed time graph for part of the race as shown in this graph. So we can divide this graph into 3 different portions. Portion A is a horizontal line. Portion B is a curve that is arcing upwards. And portion C is a straight line that is sloping upwards. So for portion A, right, because the speed remains at 0, so this portion, the car is at rest. And portion B, the steepness is increasing as the gradient of a speed time graph gives us the acceleration. We can say that the acceleration is increasing. And for section C, right, is a straight line. So the gradient is constant. This will be constant acceleration. So with this, we can conclude that the car is first at rest and then it moves with increasing acceleration. So the best option here, it has to be non-uniform acceleration, and then it moves with uniform acceleration for the last part. So the answer is D. A strip of paper tape is put at constant speed under a vibrating arm. The arm vibrates regularly, making 50 dots per second. So in this case, we know that 50 dots will be punched in 1 second. So 1 dot will be punched at an interval of 1/50th of a second. That will give us 0.02 seconds. Okay, so we want to find out what is the time taken to punch the number of dots that stretches 20 cm. So we will discount the first dot because this is the point when the time is equal to 0 second. So it will be 1 dot, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and some people do not like to count the dots, they just want to count the spacing. So counting the spacing will also give us 10. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the time taken, it has to be 10 times 0.02 seconds. That will give us 0.2 seconds. And the speed, it will be just distance divided by time. 20 cm divided by 0.2 second. We will get 100 cm per second. That will be C. Okay, I have represented these questions with a diagram. So in short, we have a trolley that is pushed by a force of 10 Newton, and then there's a friction of 2 Newtons. So the resultant force, it has to be 10 minus 2, 8 Newtons in this case, going to the right. So the answer should be B.